Hi, and welcome to this video about running an executable as system or the local system account. And so the local system account is a very famous one. It's one of the built-in Windows accounts, and it's very powerful. You can think of that as an administrator, just not having something like a normal interactive user you can work with. And so in order to create a process running with the system account, well, we have to create a process. So how would we do that? There are several functions we can use to create a process. First, we have the standard create process function. This function creates a process with the same token as the creator, the one that is doing the creation. So if I'm not system, then I can't create a process as system if I'm just using create process. That's not going to work out for me. And then there's create process as user, and create process user is definitely something we could try. However, we know that create process as user has a limit which requires a certain privilege, the assigned token privilege, which I'm unlikely to have. In fact, the system account, the local service, and network service accounts, which I use to run services in Windows, typically they have that privilege, but other users by default don't. The last option is to use create process with token W, which is much more convenient. It works differently compared to create process as user. In fact, I did a video about that a few weeks ago, so feel free to jump to that. In any case, it's much more convenient in the sense that I don't have to have that particular privilege to be able to use the function. So that's going to be perhaps a good way to go about it, at least to kind of strive to get to that function. And so the system account is special in a sense because you can't just log into a system. You don't have any password to provide to log in as system. And so we need to somehow find a system token that is a token using the system user, and then try to use that to call the appropriate or an appropriate create process function, like create process with token W. So that's going to be the thing we're going to try out. So let's go ahead and do that. So the first thing I want to show you is that we can use other tools to do something similar. One of the tools we can use is called PsExec. And PsExec is a sysinternals tool. And one of its capabilities is to run a process under system. So if I do something like -s, this is to run as system, we can try that, and it seems like nothing has happened. However, if I go to Task Manager and look for Notepad, there is Notepad here. So Notepad does exist and didn't exist previously, so it's just created. Notice it is running under the system account as I was hoping. But notice that it also is running in session 0, and session 0 is used for the system processes like the classic process Windows has, like LSAS, services, SMSS, and so on, and for services. So they're using a desktop that is invisible to us, and that's why the window of Notepad appears somewhere there, but it doesn't really it's not something I can work with directly because it's not showing up on my session. It's in a different session. And so that's not going to be good enough. Let's go ahead and break. We can break by Control-C and or just kill Notepad using Task Manager. In any case, just know that PsExec requires running with administrative privileges. And the reason is that it does its work as a service from a context of a service, which I'll show you momentarily. So let's try it again, but this time we can add the -i option. -i says interactive, which causes PsExec to launch the process in the interactive user session. That is in my session, session number 1, which would make it possible for me to see Notepad's window. And here goes, Notepad's window appears. Notice now Notepad is here running as system with session ID of 1. So it's running in my session, that's why I can see it and I can interact with it like normal. If I go ahead and try to save something, then it opens up in System32 as an example, which is in fact the default. But notice the open file dialog is in light theme. In fact, if I run a notepad like normally, here's another notepad, and do a save as or something, we'll see that it appears in dark theme because that's the theme I'm using in Windows. But this user, the system user, has a different profile, different settings, and it has most of the defaults, which are these particular light theme. So anyway, if we go back to Task Manager for a moment, you'll notice there is a service that is used behind the scenes, which is called PsExec svc.exe. That's right here, and you can go to the actual service right here, and this service launches when PsExec runs, and this is one reason it requires admin privileges, because it needs to launch a service which is by default only available to administrators, and in fact the service is doing the heavy lifting. So in fact the service is running in session 0, which means that for it to create something in the system process is kind of trivial. It can just use the normal create process function. Doesn't really need anything special there in that respect, because it's already running a system. However, we're going to attempt to do something similar without having a service on our hands. Okay, so let's go ahead and break this and kill that notepad and kill the other notepad as well, so don't get confused. By the way, it is possible with the PsExec. If you want, you can add the -d here, so it doesn't really detach from the process, doesn't really wait for it to shut down. So now you can interact with the process for as long as you like, and you can do other stuff in that command window. So that's just one little tip in PsExec, but we're more interested in coding stuff. So let's go ahead and create a new project here. Let's call that something like run as system. Run as system seems to make sense. And what I want to do here, I want to first find the process that already runs with the system account and then try to utilize that. So let's go ahead and do that. And we can choose anything really that runs as system. And if you go to Task Manager, we can look for anything, usually one of the system processes like LSAS, for instance. That would be a good target. We could use SMSS, we could use other targets, but let's stick with LSAS and see what we get. So technically, instead of just hard coding the process ID, I'm going to have a function here. Let's call that find process, whose purpose is to find a process based on some executable name, just to make it more generic and easier to experiment with other processes potentially. So I'm going to use the tool help APIs to enumerate processes, and I've demonstrated this API in one of my earlier videos. So let's go ahead and do that, even though we've seen that and it's mostly perhaps not that interesting, but still. So we have a snapshot. I know why that occurred here. So let's go ahead and create a snapshot, and what we want is a snapshot of processes. So let's go ahead and do that. And if that doesn't work out for whatever reason, and in this case this returns invalid handle value, that's what the documentation says, I'm going to return 0 as a kind of error. So now we need a process entry 32 structure there. We have to initialize the size there to the size of the structure, and then we need to call once process 32 first to get the first process. I'm not going to actually examine that, because the first process is always the idle process, so nothing really interesting is going to be there. I'm just going to go over the process 32 next until it returns false, indicating we're done, no more processes around. So let's go ahead and do that by passing the snapshot and the process entry, and now we can make the comparison. So I'm going to compare the executable name that I got to the executable name that we have in the structure here called ZWEXE file. And if this is the same, I'm doing a case insensitive comparison here, then we got our man, so to speak, or got our process. Let's go ahead and use 0 here as a default and just provide the process here by going to the th process ID. Just grab the process ID, because this is what you really need in order to later open handle to that process and move on from there. Then we can go ahead and break. And I'm doing that just because I want to properly close the handle to the snapshot. This is me just being nice, and return whatever PID has. Okay, so the first thing to do in our main function is to locate our process. So let's go ahead and do that. I'm going to call the find process function we just have written and look for lsas.exe. We can try other executables later if we so desire. So sorry, that's not going to be a hand, that's going to be a process ID. If that is 0, then obviously we have some kind of error. I'm going to just return 1 to save some time, not going to write any elaborate error messages. Once we have that, we need to grab the token of the process. For this purpose, we need to call the open process token function, but before we can do that, we have to call open process first. And so the desired access that we need here is process query information. That's the bare minimum. And that's what is required to get a token for a process after we have a handle to the process. And so we have the process ID, we're just going to pass it. And again, if that doesn't work out, there's nothing we're going to do here except returning 1 here. And we'll step through this code with the debugger, so we'll know immediately if there's any particular error there. We'll just be able to see what that is going to be. And then once we have that, we now need a handle to a token. And for this, we have to call the function open process token. So open process token requires the handle to the process. And the desired access is kind of tricky. I mean, what do I really need for the return token? What kind of access should I ask for? And let's leave that as open. Maybe you can do something like a maximum allowed, which basically says, give me as much access as I can possibly get from my perspective as just as my user running this process, this particular application called run as system. And we'll see what we actually need very soon. If that doesn't work out, it returns false. Again, nothing we can do, we can move on. And now, assuming we got to here and it's all good, we have a handle to a token now. So technically, you might want to say, you know what, maybe that's good enough. Let's go ahead and create process with token W and see if that works out. Okay, we can definitely try that. And so for that, we need to do some preparations. Let's decide what we're going to run. I'm going to stick with Notepad here, but of course you can run anything you want. If it's not in the system32 directory or not the current directory, you have to provide a full path. I recommend you do a full path unless you're creating one of these well-known executables which are in the system32 directory, because otherwise they might not be properly found. And so we have the name. We have to provide these two structures for process creation. One of them is the output, that's process information, and the other one is an input, that's startup info, which we have to at the very least initialize the first member to the size of the structure, and the rest is going to be zeroed out. And now we're ready to call the function create process with token W. We can't call create process as user. We don't have that kind of power here. We don't have the assigned primary token privilege. So we're going to go with the other option, which is more convenient. It's less powerful a little bit in terms of the fact that it requires a service that does that actually behind the scenes. And I've covered that in, as I mentioned, one of the previous videos. Anyway, we don't have to worry about that. We just need to provide the appropriate information. So here's handle to the token that we worked hard to get. There are some logon flags which we don't really care about too much. And then we need the application name and command lines. We're going to use the command line name here. Then we have the creation flags. These are the normal flags you provide to the create process function. Same idea here. So here goes. And then the environment variables. I'm going to just stick with the default here and current directory. I don't really care. And finally, we have the startup info and process information here. And we'll see what that is going to return to us. It's supposed to return a Boolean indicating success. So we'll see. So I'm going to just write here something like this and maybe just say that if okay, then, well, we can just display success or something. Otherwise, we can say failure and even display the get last error information here, just the value, just to be nice for this purpose. And then we of course have to close all the handles, but I'm not going to do that just to save time, because really they're going to be closed anyway once this application terminates. Let's just add and include here for stdio for our printf to be able to compile. Okay, it's time to test this thing, see if it works. Okay, so I'm going to go step by step. Let's go ahead and start with the first thing, which is the locating LSAS. Let's go ahead and press F5 to run this thing. Let's see if we can locate LSAS. So here goes. Do we get proper LSAS here? Let's go to autos. And we do. We have a process ID, which is 7C4. Let's just turn that into decimal. That's 1988. So if we go to task manager, we can look up LSAS, and it is the correct process ID 1988. So that's all good. Okay, we can move on. Next thing is to open a process with process query information. And this is where we fail. We can't do that. And if we take a look at what get last error has to say, it says access denied. We don't have enough powers to open a handle to the process of LSAS with this query information access mask. It makes sense because if I could do that and all the other things might also work, it means that a standard user can just get a system powers. That doesn't really make any sense. So the only way this has any chance of succeeding is if the caller is an administrator, has administrative powers. So I'm going to just relaunch Visual Studio here as an administrator. So it makes it easier to continue testing that, but now with admin powers. Notice that when Visual Studio opens up on the right, far right, top right, you can see it says admin, which is I'm running as admin right now. So now we have a better chance of success. There's no guarantees just yet, but at least we have a fighting chance. So first thing, we get the process ID. We already know that's going to work out. That's not difficult. Now open process comes into play. And this time it works. So we get a proper handle to the process, some handle with value D4. And now we're going to go to the next step, which is open process token. So let's see. And it works as well. Let's take a look at what we actually received. We have a handle. What are the powers of this handle? That might be interesting to look at. So let's look for our application run as system in Process Explorer. Here goes. We have the value of the handle of the token, which is D8. So you can see it is in fact a token that points to the system account. NT Authority System is the full name of the system account. Notice the access mask here has a read control, assign primary, a duplicate, impersonate, query source. Pretty good. We have lots of stuff here, sure. And that's what we got here when asking for maximum allowed. That is the maximum access mask I can get away with, that I can actually get with a successful status. Okay, good. We have a token and seems to be good enough. Let's go ahead and move forward with that token and try to create a process with that token. So here goes. Unfortunately, it fails. It failed. And if we look at the error, it says access denied again. And this definitely could be puzzling. I mean, why do we have access denied here? We have a pretty powerful token, and that should perhaps work. However, the problem is that this token is already being used, which means it's already used by LSAS, and the same token can't be attached to two different processes. There's no such thing. So we have to create a new token based on this token. And for that, we'll have to use another API here before we actually are able to call create process with token, which is called duplicate token EX. And duplicate token EX is kind of a unique function because it's the only one in the Windows API that is able to duplicate a kernel object. Notice it is very different than another API you might be familiar with called duplicate handle. Duplicate handle actually duplicates a handle, as the name suggests. It creates another handle to the same object. This is different. It creates a new token object that is based off the first one with some tweaks and some potential customizations. So that's what we want to do here. We want to get a new token. Let's call that a sys token or whatever we want to call that. And if that is going to work out, then great. Maybe we can use that token. So instead of using H token here, I'm going to use H sys token once we can get duplicate token EX working properly for us. So what does duplicate token EX wants? The first thing obviously is the existing token. That makes sense. And then the desired access we need for that token. And even if I don't know exactly what I need, let's go with maximum allowed. So I'm going to try to get the most powerful token I can get away with, because that's my best shot at creating a process using this token. Then there's an enumeration called impersonation level, which is not really important for our purposes here. We can select anything like security anonymous or identification or impersonation, doesn't really matter. It only matters in several scenarios if that token could be used to access another process, and that's something that is way beyond what we're trying to do here. So it doesn't really matter for that purpose, for what we need to do here. So that's that. And then we have something called a token type. There are two token types. There's a primary token, which can be attached to processes, and there are impersonation tokens, which can be attached to threads. For create process kind of function, a primary token is required. So I'm going to ask this token, the duplicate one, to be a primary token as well, just like the original one. I don't want an impersonation token because it's not what I want to do. I don't want to impersonate. I want to create a new process based off that primary token. That's going to be token primary here. And then the last parameter is the actual result, if that works as we hope. So that's going to be called in this particular way. I think I missed a parameter here. That's the security attributes we don't really care about. Some default are going to be provided for us, which is good enough. So now we can try this again. And technically, because we're calling duplicate token EX here, in terms of open process token, maximum allowed is too much. You can actually also only ask for token duplicate. That's the only thing we really want to have with this original token, because we want to use that as the basis for duplication. Okay, so let's try it again. Okay, so we find the process, great. We open a handle to the process of LSAS in this case. Good, now we have open process token. It works, no big surprise here. Now we get to the duplication part. So here goes, we got the duplication. Let's see if it works. It works. We get HC's token here. We skipped everything here. Now we're using this HC's token as the basis for create process with token W. And here goes, we get Notepad. Let's verify. Let's go to Process Explorer here, look for Notepad. Here's our Notepad. It was just created. Notice it's running as system. It's also running in session 1. That's we are able to see that. That's the default here, which in this case is exactly what we want. So we don't have the session here. I need to make it visible if I missed that somehow. So let's see if we have the session here. Here goes, session. So session is indeed, let's bring it in a more convenient location here. Here's the session for Notepad. It's session number 1, right? So session number 1, as we expected, and this is what we actually wanted. But of course, we could have perhaps changed it in some way, but not with this simple function in this case, and not with the power that we have for our token. If we double click Notepad, by the way, we can see the security tab. Now, the security tab in Process Explorer, the name is a bit misleading. It's really about token. It should have actually been called token. It really shows the properties of the primary token. You can see it is the system account, and that's it's a very famous seed. You can see that it's session 1. This is where the process is running. This is also information which is stored in the token. It's not a protected process, not virtualized. We can see that it has a bunch of groups here, and we can see all the particular privileges this particular process has, which is based on that token. And for example, you can see there's something very powerful here, which is the create token privilege. This is an API that allows you to create a token from scratch. So the API itself is called NT-create token, but this privilege is required and normally only LSAS has it. But now we have it as well, which means we can create a token from scratch, which is super powerful, because with a token from scratch, you can put in it anything you want, all the privileges that you'd like, all the groups that you want, you can put everything you want in there. So that's kind of a superpower. And so it just shows you that it actually matters which process we try to duplicate its token, because some other process that still might be running under the system account might have different set of privileges. This is the typical case for services, because services running with the system account can choose the privileges that they want. So you get what that token gives you. It's not something that you can change. And that's because privileges cannot be added or removed from a token. The only way to do that is by, well, if you build token from scratch, then you can, but once a token is already built, then it's a done deal. The set of privileges cannot be changed. The way to do that in a normal way is to go to the user database, make change there as administrator, and then the next time that particular user logs off and logs on again, then things will change in terms of privileges. But for the system account, it's not something you can easily control, or in a very kind of I would say free manner. It's really only about services typically, or if you have the create token privilege, then you can create a token from scratch and build anything you want into it. And so if we try to compare that with LSAS, then we should see exactly the same thing, the same properties, because we just duplicated the token, we didn't make any changes, so we see basically the same thing, except for the session, which was changed to in the new process, because we called create process from process in session 1. That was the only visible change here. The other things seem to be identical, like the create token privilege, of course, and all other privileges that we have in this particular token. So you can see all that kind of stuff. And of course, you can use the kernel debugger as well to see these things if you care, but I'm not going to cover that in this video. And so notice that in some cases, this may or may not work. So let's say I want to try something else. Let's go ahead and grab something like SMSS. So SMSS also is running a system. Maybe I want to try to use its token. Maybe its token is nicer. Maybe it has some more privileges that I care about. Of course, we can look at that by looking for SMSS in Process Explorer, double clicking and seeing what its token has. So maybe it has some privileges I really like and I want to try this one. However, this is not going to be that easy, but we can try. Let's see if we can get this to work. So here's SMSS. So I'm going to change that and just run it again. And this time, let's see, we find the process ID of SMSS. That was easy. Then we try to open a handler to the process, and this is where we fail. We fail. If you look at the error, we can see that it's access denied. And unfortunately, there's no way around it. There's no way around it from user mode. And that's because SMSS is a protected process. You can see SMSS has this protection. You can see there's a protection column we can show called PS protected signer WinTCB Lite. It doesn't really matter what that means at this point, but it's important it's a protected process. And for protected processes, there's no way to get a handle with process query information access mask. You can only get process query limited information access mask, which is not enough to get a proper token for that kind of process. And so from user mode only, without any kernel powers, we can't duplicate any token that belongs to any of these protected processes. You can see here those with this particular fuchsia color. So we can't do that. I can even sort by protection. You see all these things are protected. We can't use that. You can't use a defender, for example, or any of the other process you see here because they're protected process. You can't open a powerful enough handle to their process in order to duplicate their handle. But LSAS is something we can do, at least on Windows 10. By the way, in recent versions of Windows 11, LSAS is also running protected by default, which means that will not work on newer versions of Windows 11. You'll have to find someone else. But there are quite a bit of processes running with a system account that are not protected, mainly services. So you can definitely grab some other process with a system account, but of course it might not have all the privileges you might like. But still, system account has some special powers like create process as user, for example, and other potential privileges that are really powerful, like the TCP privilege, TCP, the trust compute base privilege, which is super powerful, that many system-based processes have. So you can experiment and just look around, see which process seems to be more promising. So that's what we have here, the ability to create a process running under the system account. Of course, you have to choose one that you can actually access. Even as an administrator, this is not always something you can do because protected processes are off limits.